Hello students, good evening all. So welcome back to our next session of chapter sequences and series. So far we have discussed the introduction part of it and then we entered into our arithmetic progression. So we'll just have a quick overview, recap of the topics that we have discussed earlier and as well as the today's concepts. So we'll just have a basic brief introduction to today's topics that we are going to cover in our today's session. So if you guys have any questions from the previous topics that we have already covered, you can please let me know in the comment section. So in our previous session, we have discussed about the series of AP. So we already discussed the introduction, in the introduction part, the basic definition of series. So when it comes to arithmetic progression, so how it will be dealing with it and what will be the typical rule and formulation with respect to this arithmetic progression. So that and all we have seen. So basically in arithmetic progression, the series will be represented using this symbol Sn and it will be equal to n by 2, 2a plus n minus 1 into d. So this is our sum of, that is nothing but series of the AP, sum of the terms which are present in the particular sequence, right? So this can be rewritten in another way, which is nothing but n by 2 into a plus l, where a is the first term of the progression, arithmetic progression, and l is the last term of the arithmetic progression. So these two we have seen and we have even done questions related to this series of AP. And after this series of an AP, we have seen a topic that is splitting of a number, right? So the splitting of a number, but whereas the condition here is the number should be in terms of the arithmetic progression, right? So the numbers must be splitted into different parts. So it can be 3 parts, it can be 4 parts, it can be 5 parts. So whatever the number of parts here, those must be splitted such that there should be in arithmetic progression, right? So I have given you a rough idea how we'll be taking the numbers here. If we have to split it into 3 parts, it should be started with a minus d and a plus d in order to eliminate the common difference, and we could directly get the a value, and there will be another condition which will be mentioned in the question. Using that condition, we can able to predict the another unknown term, that is the d here. So this is for 3 terms. So what will happen, what will be the terms when we have to split the number into 4 terms? Can anyone please let me know? So what will be the terms here if we want to split a number into 4 different parts such that those numbers must be in an AP? So can anyone let me know? Okay, Saryu and Ridhishri are here. So can you guys let me know? So just in our previous class, we have discussed this concept, guys. So I have given you for 3 parts. So can you guys tell me the answer for 4 parts? So how we'll be taking when you have to split a number into 4 different parts such that those 4 parts should be in an arithmetic progression. So how we are going to take those 4 different parts here? Quickly, guys. So we have done a question related to these 4 parts in our previous session. So I hope you guys remember that. Okay. Jagadish has given here a minus d, a plus d and a plus 2d. So if you see the order that you have given here, that is a minus d, a plus d and a plus 2d. So the trick here, which we are taking these terms in order to eliminate the one of the term, that is common difference. So as the terms, if you have given Jagdish here, a minus d, a plus d, and a plus 2d. So we have splitted a given number into these 4 different parts. If we sum this, we'll be remaining with 4a plus 2d, which means we are not eliminating exactly our one of the term, that is d here. So this must not be the exact order. So for 4 parts, it should be a minus 3d, a minus d, and then a plus d, and a plus 3d. So now for this order of terms, if we do the sum of the terms, which means if we are having 32, this has been divided into 4 parts. So the sum of these 4 parts should be equal to 32. So the same part application here. So the sum of all this must be equal to the given number. Right. So if we do this sum of these given terms, then plus 3d and minus 3d will be eliminated, as well as minus d and plus d will also eliminated, and that means we are actually eliminating one of the unknown here, and we'll be directly getting the a value here. So that's the only trick while taking the terms when we have the splitting of a number here. So if we have 4 terms, so if we have to divide into 4 parts, it must be a minus 3d, a minus d, a plus d, and a plus 3d. If for suppose we have to split into 5 different parts, then it will be the middle term will be coming into picture. That means a minus 3d, a minus d, a, and then a plus d, a plus 3d. So this will be the typical order how we are going to take the parts of the numbers when we are having the splitting of a number, such that the order the numbers must be in an AP. Right. So these are the 2 typical topics which we have covered in our previous session. So I hope you guys are clear with these 2 topics of series of AP as well as splitting of a number. So coming up, if you have any doubts and questions, you can let me know. So coming to our today's topics, we are going to start with this arithmetic mean. So I hope you might have familiar with this arithmetic mean, which is nothing but average of 2 terms. But there will be one more additional topic here, inserting the arithmetic means between any 2 numbers. So that will be the new and different concept that you are going to learn in our today's session, which is related to the arithmetic mean. Right. So this will be our topic, today's topic, arithmetic mean. And with this arithmetic mean, we are almost done with the arithmetic progression. And then we are jumping into our next progression, which is geometric progression. And as usual, we'll be starting with the typical definition of it and the representation of it and the terminology related to the geometric progression. Each and everything we are going to discuss in the introduction part. And then the general term, everything we are going to cover here in the geometric progression. And then after the discussion of this general term and the terminology related to the geometric progression, the next topic, that means which is followed by this geometric progression here, is the series of GP. Like how we have discussed the series of AP, in a similar way we are going to discuss the series of AP, and with that we'll be continuing our next part. If possible, we'll just add our geometric mean also in our today's session. Right. So I hope you guys are clear with these 2 typical topics. So let's just start with our today's session. So before discussing this arithmetic mean, so let's just discuss an important property which is related to this arithmetic progression. Right. A sequence is said to be an arithmetic progression if the sum of its n terms is of the form an square plus bn, where a and b are constants. Thus, the common difference of the AP is 2a. Right. So, what is our sum of n terms? That is Sn, n by 2, 2a plus n minus 1 into d. So, this is our sum of n terms of an AP. So, this can be rewritten in terms of, Sn can be rewritten in terms of an square plus bn. So, if Sn can be represented in this point of view, that in this manner of an square plus bn, then directly from this representation, you can directly state that the common difference here will be directly equal to 2 into this constant a. Right. So this is one way of representing our sum of the terms, sum of the n terms we can say. So if we are if for suppose in any given question the sum of n terms of an AP has been represented in this format of a into n square plus bn. So there is no need to reduce this into this typical standard format in order to find the common difference. So from this equation, from this representation itself, we can determine the common difference of the arithmetic progression, which is given by 2 into this capital A. Right. So this is one of the important property which is related to the arithmetic progression here. And this is relation to our common difference as well as the sum of its n terms of an AP. Right. So now let's move on to our most important topic here, that is arithmetic mean. So first we'll just start with the basic definition here. So arithmetic mean is represented with, you can say, A. So we'll be representing with this capital letter A. So arithmetic mean of any two given numbers. So if for suppose we are having two numbers A and B, and we are here supposed to find the average, that is arithmetic mean of these two numbers, then the arithmetic mean of these two given numbers A and B will be equal to A plus B by 2. It's just that simply the average of these two given numbers. Right. So let's check here. So this is the standard arithmetic mean. Right. So arithmetic mean will be equal to A plus B by 2. So that means arithmetic mean of any two numbers will be equal to A plus B by 2 here. Right. So here there is a new concept that we are going to learn in this arithmetic mean concept, that is inserting an arithmetic means between given two numbers. Right. So for suppose there is a sequence which is starting with the first term A and ending with the last term B. And in between we have inserted some n arithmetic means here. So here these are not only the terms in the sequence, but they are n arithmetic means. Right. That means the general representation of arithmetic mean will be A, which is given by A plus B by 2. Right. So here as we are inserting some n, that means average of these two and then average of these two, average of these two. Likewise, it will be coming. So that we are going to represent with A1, A2, A3 and so on. As here we are talking about n, so it will be n. So here we are having two numbers A and B. In between these two numbers A and B, we have inserted some n arithmetic means which are given by A1, A2, A3 and so on an. So now the sequence, now the arithmetic progression has been turned out to be, the sequence has been turned out to be small a, capital A1, capital A2, capital A3 and so on, capital A1 and B. Right. So for this we have to figure out the common difference, the last term, that is the nth term, right, as well as the common difference here. Right. So here if you observe how many number of terms here, so total terms. So n arithmetic means plus A plus B, that means total terms here will be n plus 2. So total terms here will be n plus 2 and the first term here is A and the last term here is B. So last term is given by, so that means last term is nothing but n plus 2th term here will be equal to B, because that is the last term here. Right. So that means the last term here, according to our arithmetic progression, it will be equal to A plus, here how many terms we are having? N plus 2 terms. So n plus 2 minus 1 into common difference. So our general last term formula, that is nth term formula, is given by A plus n minus 1 into D. So this is our general format, right, where we have n terms in that particular progression. Whereas in this particular progression, if you guys observe, we are having total n plus 2 terms. right? That means in place of n, we are going to replace with n plus 2. So that's what I have written here. And the last term here in this progression is b. So here b will be equal to a plus, in place of n, it must be n plus 2. So n plus 2 minus 1 into d. Then b will be equal to a plus n plus 1 into d. Right. So far, what and all we have predicted from this given progression. We have predicted the total number of terms which are given by n plus 2 terms, and the last term which is equal to b is equal to a plus n plus 1 into d. So using this last term only, we are trying to figure out the common difference here. So I hope you guys are okay so far. So here b is equal to a plus n plus 1 d. Just now we have determined. So now what we have to do? We have to find the d value, that is the common difference. So let's rewrite the equation here. So b minus a here will be equal to n plus 1 into d. And then b minus a divided by n plus 1 is equal to d. Which means for that particular arithmetic progression, common difference will be equal to b minus a by n plus 1. That is last term minus first term divided by total and how many number of arithmetic means we have inserted, that plus 1 will be giving us the common difference d for that progression, which is as follows: a comma capital A1, capital A2 and so on until an and b. So for this progression, we have predicted our three results here. First one, total terms will be equal to n plus 2, and the last term which is b equal to a plus n plus 1 into d, and then the common difference d will be equal to b minus a by n plus 1. Right, so I hope you guys are understanding this concept. So if you have any doubts so far, you can ask me. If not, we just move ahead with our concept. If you have any questions in this regard, you can let me know, guys. If you're clear, we'll just move ahead with our next concepts. So there is nothing new here. It's also an arithmetic progression, but there are two numbers a and b. In between, we have inserted some other arithmetic means which are represented by a1, a2, a3 and so on an. So now the AP has been turned out to be, the sequence has been turned out to be a comma capital A1, capital A2 and so on a and b. So which indicates that total number of terms in this progression is given by n plus 2, and the last term b will be equated to a plus n plus 1 into d, and then from here, from the second result, we could determine the common difference d, which is given by b minus a by n plus 1. So far no doubt. So let's move ahead with our concept. So now as we have inserted some n arithmetic means between two numbers, so now the question is sum of the n arithmetic inserted means between a and b. That means we have to find the sum of a1 plus a2 plus a3 plus and so on until an. So our sequence right now is a comma a1 a2 and so on an b, and the common difference d equal to b minus a by n plus 1 and b last term equal to a plus n plus 1 into d, and total number of terms will be equal to n plus 2. But here the question is we have to find the sum of this n arithmetic means. That means capital A1 plus capital A2 plus capital A3 and so on until capital A1. So you have to find this value. Can you guys give it a try for this and let me know what will be equal to this sum of this n arithmetic means which are inserted in between the two numbers a and b. Quickly give it a try. So relate to your common difference, last term and everything here. So try and write that in terms of common difference and the first term. Give it a try, guys. Can anyone tell me what will be this capital A1 equal to in terms of the common difference as well as the first term? Capital A1, because we know that this is the arithmetic progression here. So just let me know A1 equal to first step. That will be our first step here in order to get the result. So what is our general AP? So if A is my first term, second term will be A plus D. Third term will be A plus 2D. So here common difference is D, which means my capital A1. So let me write it here. My capital A1, which is the second term in my AP, will be equal to A plus D. Then my second A2 will be equal to, as it's a third term. So third term here will be equal to A plus 2D. And then A3 will be equal to A plus 3D. So likewise until AN, so AN will be equal to A plus ND. Did you get this relation of A, capital A, small a as well as our common difference here? Because once we get the idea of this concept, then the remaining will be just as the substitution and simplifying it further. So you guys have any doubts in regard of this capital A1 equal to A plus D, capital A2 equal to A plus 2D and so on? Let me know if you have any queries in this part. So it's just like our arithmetic progression. So now I hope no doubts. So as we have now represented our A1, A2, A3 until AN in terms of AN and D. So let's just substitute that, because here we have to find the sum of this n arithmetic means which are represented by capital A1, capital A2 and so on until AN. So this will be A plus D and then capital A2, A plus 2D and so on until A plus ND. So here you can see our A will be repeated n times. That means this can be written as NA. So this is nothing but our sigma AN, right? When, or we can say AI. Sigma AI, I will be equal to 1 to n. Right, so this is nothing but sigma AI, where I will be equal to 1 to n. So as A is repeating n times, so we can take that as NA, and then we'll be remaining with D plus, 2D plus, 3D plus and so on ND. Again we can take D common here, right? So NA plus, if we take D common, it will be equal to 1 plus, 2 plus, 3 plus and so on until, and that means it is nothing but sum of the n terms, right? So now let's use the formula of sum of the n terms. So NA plus D into sum of the n terms is given by n into n plus 1 by 2, right? So this is our sigma, but here in place of D we can substitute the formula which we have determined earlier. So let's just use that here. I'm just erasing this part. Okay. So far we are having sigma AI, where I from 1 to n. So we so far have NA plus D into n plus 1 by 2. And we have already determined for this progression D is equal to B minus A by n plus 1. So now we are going to use this common difference formula and substitute in this equation. So NA plus b minus a by n plus 1 into n plus 1 divided by 2. So this n plus 1 and n plus 1 will be getting cancelled, and we are going to remain with na plus nb by 2 minus na by 2. Right, so now as it's na minus na by 2, so then it will be na by 2 plus nb by 2. So from here n by 2 can be taken common, so n by 2 into a plus b. So now this sigma ai, where I is from 1 to n, will be equal to n into a plus b by 2. So in the beginning of this arithmetic mean itself, we have seen that capital A is nothing but the arithmetic mean of the two numbers, which is given by a plus b by 2. So now that a can be substituted here, which means n into a. That means we can say that the sum of the n inserted arithmetic means between any two numbers will be directly equal to, that is sigma ai, where I is equal to 1 to n, will be directly equal to the number of arithmetic means which we have inserted, that is n, into the average of these two numbers a and b. That means directly equal to n into capital A. Right? Okay. So no doubts. So here that's what we have to determine. We have to determine the sum of this n arithmetic means which are inserted between these two numbers a and b, and we have determined that is equal to n into capital A. That means if we have if there is a question raised like find the sum of some 6 arithmetic means inserted between, okay, let me raise a question here. So if for suppose we have to find sum of 6 arithmetic means inserted between some 50 and some 300. So if we want to find the sum of 6 arithmetic means which are inserted between these two numbers, right? So then we can directly say that it will be equal to 6 into average of these two numbers, which is 50 plus 300 divided by 2. That means here it will be 3 times. So 350 into 3. So directly the sum of the 6 arithmetic means which will be inserted between these two numbers 50 and 300 is equal to 1050. So there is no requirement here. We have to find, there is no need to find those arithmetic means. Instead, we can directly use this formula that we have derived just now in order to figure out the sum of those n arithmetic means. So I hope you guys are clear with this arithmetic means concept and finding the sum of the n arithmetic means which are inserted between the two numbers a and b here. So if you guys are okay with this, we can just move ahead and let's deal with the questions related to the arithmetic mean here. Please let me know guys if you have any doubts and all. If not, we'll just move ahead with the questions related to this concept of arithmetic mean. Okay, so far no doubts. So let's do this question. So as I have explained you one of the question, I hope you guys can give it a try. So here the question is insert 20 arithmetic means between the numbers 4 and 67. So you have to write the arithmetic progression here, inserting 20 arithmetic means between the given two numbers 4 and 67. So quickly do that. So far we have determined our b will be equal to a plus n plus 1 into d, and the common difference d will be equal to b minus a by n plus 1. So just compare the standard terms to our given information in order to figure out the progression here. So I'm not going to ask the to write all the 20 terms here. So you can just write the first 3 terms and the last 2-3 terms. That will be fine. So give it a try, guys, while solving it. If you have any questions, if you are facing any difficulty, you can please let me know. I'll just help you with that. Excuse me. So let's see if anyone done solving it. You can let me know the answer. So here the sequence should be 4 comma A1, A2, sorry, A3, and so on. So 20, right? So A19 and A20 and then 67. So this should be the sequence, that is the progression here, and you just try to find these values A1, A2, A3, A19 and A20. So no need to find the intermediate values here. Just try to find these 5 values. That would be enough to represent the progression here. So here you need to figure out only the common difference. So once you could able to determine the common difference, you can directly predict the A1, A2 and A3 values, because just now we have seen the relation between the common difference first term as well as our A1, A2 terms, because it's in the arithmetic progression here. So here we are having the common difference formula also. Just figure out the values and try to find the common difference here. Okay. 7, 10, 61, 64 and 67. Can you check the last terms? Okay. Done. 7, 10, 13. Okay, fine. Jagdish has given the answer. So here common difference will be equal to B. What is the B value? That is 67. So 67 minus A will be 4. And here is, we have to insert 20. So it will be 20 and plus 1. So 67 minus 4 will be 63 by 21. So this will be getting cancelled in 3 times. That means the value of the common difference here will be equal to 3. So if the common difference is 3, then the progression will be 4. 4 plus 3 will be 7. 7 plus 3, 10. 10 plus 3, 13. And so on. So here until 67. So as it's a 3, so 64. And then here 61. So this will be the progression here when we insert 20 arithmetic means between the given numbers 4 and 67. So only one of you has given the answer. So what about others? Any doubts in this? Okay, I hope no doubt. So this is a basic level question. So let's just move a bit difficulty level. So try and read this question and try to answer this. So this is related to the arithmetic mean again. This is a JE level question. So give it a try, guys. I'll just check the messages. If anyone has any doubts, you can please let me know. So M arithmetic means are inserted in such a way that the ratio of the 7th and the M minus 1th means is 5:9. That means 7th arithmetic mean as well as M minus 1th arithmetic means ratio should be equal to 5:9. And here we have to figure out the value of M. Let's see how we will be doing this project. Same methodology that we have obtained for our previous one. It should be, N should be a natural number, right? It shouldn't be in decimals. Can you just check your answer once, Jagdish? It should be a natural number because we cannot insert some 13.6 terms in between any two number, right? We are going to insert some N natural number terms, that is N natural number arithmetic means. So here M arithmetic means in the sense it will be a natural number. Just check your calculation once. So what about others, guys? So here between 1 and 31, M arithmetic means are inserted. So our progression, our AP will be 1 comma A1, A2 and so on AM comma 31. Right. So according to our terms, this will be T1, this will be T2, this will be T3 and so on. This will be Tm plus 2 and this will be Tm plus 1. Right. So this is our arithmetic progression here, which is given by 1 comma capital A1 comma capital A2 until capital AM comma 31. So 1 here, the first term, that is T1 will be equal to 1. So T1 here will be equal to 1. That means T2 here will be equal to A2 and so on. Tm plus 2, that is our last term, will be equal to 31 because we will be having M plus 2 terms in this particular arithmetic progression. So now the condition which they have mentioned here is such that the ratio of the 7th and M minus 1th mean. That means the ratio of A7 and AM minus 1 should be equal to 5/9. So here they are not talking about the terms. So instead they are talking about the means. That means the 7th and the M minus 1th mean, which means A7 by AM minus 1 should be equal to 5/9. So here A7 in the sense that term will be T8 and Tm minus 1 will be Am minus 1 will be the term Tm in terms of terms. So we have to figure out the term that is the value of this A7 and Am minus 1. So this is nothing but T8 by Tm. So try to figure out the value in terms of the first term as well as the common difference here. So I just converted in terms of our general terms in order to write our progression easily, because we just followed with our general format. So if we are having Tn, it will be equal to A plus n minus 1 into D. So in order to use this, I just written in terms of terms also, so that we couldn't get confused while writing the terms here. So let's see if anyone has already given the answer. Not yet. So let's see here. We have to figure out the ratio, that is A7 by Am minus 1. That will be equal to 59. So this is given information. So by comparing this, our sequence, this A7 is nothing but the 8th term in the progression, and Am minus 1 is nothing but the Tmth term, that is mth term in the progression. Right. So 8th term is equal to A plus 7D, as well as mth term is equal to A plus m minus 1 into D. So here A value is equal to 1. That means the ratio here will be 1 plus 7D by 1 plus m minus 1 into D is equal to 5 by 9. So now as we have the terms, so let's try and figure out the common difference D using the formula. So D will be equal to B minus A by n plus 1, that is number of arithmetic means inserted here. So that is not given here, which means it will be in terms of m only. So D here will be equal to B minus A by m plus 1. So B is 31 and A is 1. So m plus 1, that means common difference D here will be equal to 30 by 1 plus m. So now if you replace this common difference D in terms of with respect to this m, so the entire equation will be in terms of m, and here we have to calculate the value of m only. So can you guys figure out the value here? Anyone? So far if you have any doubts, so while writing this ratio part or while determining this common difference D, if you guys have any doubts, you can let me know. Because there is one small clumsy part here that might confuse you guys. That is, here they are talking about the ratio of 7th and m minus 1th means. That means A7 by A minus 1 ratio they are talking about. Right. So when we convert that in terms of our general progression terms, this A7 is nothing but the 8th term in the progression, and this A minus 1 is nothing but the mth term in the progression. So according to this 8th term and nth term of the progression, that will be equal to A plus 7D, and mtm will be equal to A plus m minus 1 into D, from where after substituting the A value 1, we end up having the ratio as 1 plus 7D by 1 plus m minus 1 into D equal to 5 by 9. And now we have to figure out this common difference. Here we just find out the common difference using the formula, which is equal to 30 by 1 plus m. So this is the ratio. So let's substitute the common difference d here. So 1 plus 7 into 30 by 1 plus m divided by 1 plus m minus 1 into 30 by 1 plus m. So now I hope we can take the LCM and we can eliminate this m plus 1 or 1 plus m. So it will be m plus 1 plus 7 into 30, 210 divided by, so here it will be m plus 1 plus m plus 1 into 30, that means 30m minus 30. So as in the denominator, 1 plus m will be getting cancelled and this will be equal to 5 by 9. So now what we have to do, we have to simply do the cross multiplication in order to predict the value. So here it will be m plus 211 by 31m, 1 minus 30, that means minus 29 equal to 5. So this will be the ratio so far. So in order to predict the m value, just simply do the cross multiplication here. Right, so it will be 9m plus 9, 9, 1899. So 211 into 9. So here it will be equal to 31 into m, that means 5 and 15. So 155m minus 29 into 5, which is 45, 145. Right, so now let's bring the m terms together and the other terms to the other side. That means 155m minus 9m, so this side, and 1899 plus 145 here. Right, so 155m minus 9 will be 146m and 1899 plus 145, 9, and it will be 4, and 9 plus 4, 0 and 2. So now we are having the relation, that is 146m equal to 2044, where m here will be equal to 2044 divided by 146, which this will be getting cancelled in 14 times. So where the m value here, that is the unknown value which we have to calculate, the number of arithmetic means inserted in between these two numbers 1 and 32 are given by 14, which means 14 arithmetic means has been inserted between the given two numbers 1 as well as 31. So I hope you guys are clear with this question. So it's just that we have to substitute d here in order to get the entire equation in terms of m, which is the unknown which we have to calculate here. So if you guys have any doubts in this particular question, please let me know the questions. Let me know your queries. If not, we'll just move on to our next one. Come on guys, quickly. So I hope Jagdish, you might have checked your calculation error somewhere, I think. I hope. Okay, so far no questions. So that's all with our arithmetic mean and inserting some arithmetic means between any two given numbers. So now let's move on to our next concept, that is geometric progression. Right. So in first, as I mentioned, we'll just start with the basic definition and then terminology involved in it. And then we'll move into our general term and so on. Right. So a sequence of non-zero numbers is called a geometric progression. Right. So a sequence of non-zero numbers is called to be a geometric progression, which is GP. Okay, you have figured out the calculation. Okay, fine. So if the ratio of successive terms is constant, so for our arithmetic progression, it will be the common difference. So the difference must be constant. Whereas in geometric progression, it's the ratio of the successive terms is constant. So that's the basic difference between our geometric progression as well as the arithmetic progression. So in our arithmetic progression, we'll be talking about the difference, common difference, whereas in the geometric progression, we'll be talking about the ratio. Right. So the ratio of the successive terms will be constant here in this particular sequence. So in general, if we write a GP, that is in general, if we write a geometric progression, it will be given in the format of A, that will be the first term, and then as here for geometric progression, it will be the ratio, then it will be AR second term, and then AR square third term, AR cube, and so on. So likewise, it will be going. Right, so sometimes it can be represented in our suffix also. So A, AR1, AR2, AR3 and so on. So where here R is the common ratio. So in arithmetic progression, we'll be talking about D, which is the common difference. Whereas in geometric progression, we are going to talk about R, which is the common ratio here. So now as we have seen our standard general progression of the geometric progression, that is A, AR, AR square, AR cube and so on. Then our last term will be A into R power. So this is my first term T1, this is second term T2, this is third term T3, T4 and this will be my nth term. So if we compare the power, that is my index, as well as the term number here, it will be the power is one less than the term. That means here it should be n minus 1. So the standard format of this geometric progression will be equal to A comma AR comma AR square, AR cube, AR power 4 and so on until A into R power n minus 1. Whereas A will be my first term, AR will be my second term, AR square will be my third term and so on. So here I can say my general term Tn will be equal to A into R power n minus 1 in my geometric progression here. So let's do a question related to this geometric progression, which in terms of which is related to the terms involved in the geometric progression. So for this, it will be enough if you are familiar with the geometric progression standard, that is A, AR, AR square and so on, A into R power n minus 1. So how we are trying to predict the R here? R will be equal to T n plus 1 divided by, n minus 1. 1 second. So this is our GP A, AR, AR square and so on, AR power n minus 1. So from here R can be AR by A, that means T2 by T1. Similarly, R can be predicted by T3 by T2, that means Tn by Tn minus 1. So you can determine the common ratio R by Tn by Tn minus 1. So read the given question and try to find the relation here. So the 5th, 8th and the 11th terms of a GP are given as P, Q and S. Sorry, I hope it will be P, Q and R. So you have to try to figure out the relation between these two. Sorry, it will be P, Q and S only, because here we are representing with the R will be represented with common ratio. So it should be S. So what is our general progression? So A, AR, AR square and so on, AR power n minus 1, and common ratio can be predicted by T n by T n minus 1. So now the 5th term, 8th term as well as the 11th term of a GP has been given by P, Q and S respectively. So we have to find the relation between these three, that is P, Q and S here. So quickly give it a try, guys. I'll just check the comment section. If you guys have any queries, any doubts, you can let me know there. So try to figure out the fifth term and all, because we know the general term here, that is Tn in a geometric progression will be equal to a into r power n minus 1. So from where you can try to figure out the fifth term, eighth term and 11th term and equate that to our PQS which are given here. So here we have to write the fifth term, that is T5, which will be equal to a into r power 5 minus 1, which is a into r power 4. Similarly, eighth term, that is T8. Try to write the eighth term as well as the 11th terms using the same format here. So let's write the eighth term also. So it will be a into r power 8 minus 1, which is given by a into r power 7. And for 11th, it will be a into r power 11 minus 1. That means a into r power 10. So this is my fifth term, eighth term as well as 11th term. And they have been given as fifth term equal to P and eighth term equal to Q and 11th term equal to S. That means here P equal to a r power 4 and Q equal to a r power 7 and S equal to a r power 10. So now we have to determine the relation between these two. So for suppose here, if you see the powers, if we add, can we get any relation here? No, right? But let's try it by taking the square of it. So if we take square of it, 4 square, it will be here with square, it will be 8. But it will be less than this. So square of this, that will be 14 and 10 plus 4 will be 14. That means we must do the q square, which is equal to a square and r power 14. Right. So if we do this q square, so here this will be equal to product of this P and S, which is given by a square into r power 14. That means the relation here between these three PQS is given by q square is equal to PS. Because P is equal to a power r power 4 and S equal to a into r power 10. The product of these two PQS is nothing but a into a square, and these two r in r power 4 into r power 10, that is r power 14. So this PS is nothing but a square r power 14, and if we do the q square also, we end up having this a square r power 14. That means q square is nothing but equal to PS. So the relation between these three P, Q and S is given by q square is equal to P into S. So anyone has already got the answer? Okay. So that's all for today. So we have started with our geometric progression. We have finished our arithmetic part of it, arithmetic progression, and we have started with our geometric progression, and we have discussed the basic introduction part of it, which is related to the terms and everything, common ratio and all. So in our next session, we'll just continue our geometric progression and start discussing the series of geometric progression and geometric mean and the terms related to our geometric progression. So I hope you guys have understood our today's session. So if you have any doubts and any questions from this particular session or the chapter, you can let me know. whenever it will be, I'll be free to ask. It will be free for you to ask the questions. So that's all for today. I hope you guys have understood the session. So thank you guys. So let's just continue the rest in our next session. Thank you.